So tell me how best you would have solved this question. So I'm asked to find the area of the circle below. So first of all, I want us to extract I extracted the triangle that is inside. Sorry, this is a pass. So I have A, B, C, and this is what we have as a triangle, right? Now we know that sum of angles in a triangle is 180 degrees. Now if you see, please, anytime you see a triangle with this corner shape, it means 90 degrees. So we have two angles given here, 90, 60. This is the part that is missing as shown here. So it means we can easily find this angle, and that is 90 plus 60. So let us denote that angle down there as A. The three of them should sum up to 180 degrees. So this plus this will give me 150 plus A, which is equal to 180 degrees. So we want A to stand alone. So you subtract 150 from both sides. So this will turn to 0. So where A is, 0 minus 0 is 0, 8 minus 5 is 3. So it means the place where A is 30 degrees. So let me draw this and explain what I did. So here is 90 degrees, here is 60, and we discover that here is 30. But if we take a look at this triangle very well, it is showing that it is half of a triangle. So let us complete it. Now let us complete this. Now similar angles, this angle here is similar to this one. So this is 60 degrees. Then if we extend this is 90 degrees. If we come here, this is similar to this. So if we total this is 60 degrees. Now forget the 90 degrees and let's talk about the angles. We have a triangle and each is 60, 60, 60. So since we discovered that all the angles measure 60 degrees, this takes us to a special type of triangle. Now, a triangle with equal angles of 60 degrees each is called equilateral triangle. Now, there's something very unique about equilateral triangle. If here is 2, here is going to be 2, and here is also going to be 2. That's why we say all the sizes are equal, measuring 2 centimeters, inches, or whichever way. Now, let's go back to this place. It therefore means that this angle, this line AC is 2 centimeters. And if we now come here, the whole of this length is 2 centimeters. But there is a line bisecting it into 2 equal parts. So if I have 2 as a total, it means 1 is going this side, 1 is going this side. So this 1 centimeter is the length captured there. So it is very, very simple to define the other side. We have 60, we have 90, 2, 1, we have 30. So funny enough, there's actually a trick to finding this without you applying Pythagoras theory. When you have 30, 60, 90, then there's a trick that add up the other 2 and take the square root. So 1 plus 2 will give me 3, then this will be the root of 3. But since we are not familiar with it, you can use Pythagoras theory. So Pythagoras theory says that this arrangement is based on the numbering of the angles. When you are numbering angles with respect to size, that size with respect to angles, the opposite sides bears the smaller letter of the angle. So you see, this is the side facing A, this is the side facing B, and this is the side facing C. Now Pythagoras theory says that Whenever you are looking for any angle, the longest line, which we call the hypotenuse, if you square it, it is going to give you the square of these two other sides when you sum them up. So we already have B, which is given as 2. So this is 2 squared. Now A, look at the position of A, we found it as 1, that is 1 square, plus C, which is the height we are looking for here, and this is 6 square, which is unknown. So 2 square is 4, which is equal to 1 square is still 1, plus 6 square again, minus 1 from both sides, so that C will stand alone. 4 minus 1 will give me 3 equal to 6 square. In my other videos, I explained that anytime you have a square and you want to remove it, take square root on both sides. So square will cancel this, and C is now equal to 3. Already I told you something, that when you have 30, 60, 90 degrees and you are looking for any side, you subtract or you add. So 2 plus this is 3 plus that, and this gives us 3. So please, let's take a look at this. I'm rewriting the shape so that we understand. I have 1, I have 2, and I have root of 3. But from the diagram given, this is our final answer from our findings there. We have 1 here, we have 2 here, we have root 3. Now compare these two shapes. Compare the two shapes and see. Compare the size of the triangle. You discover that this side is the same with this side. This side is the same with this, and this is the same. But something happened to this side. There is a scalar multiplication of 4. That is, for each of the values here, there is a scalar multiplication of 4. So just the same way that I have done here, come here and multiply your 4, come here and multiply your 4, so that we get the exact measurement of this. So this is already here. So 1 times 4 will give me 4, and 2 times 4 will give me 8. So let's come here. Now we are here to solve the shape. I was doing all of that to explain how I solved this. Now if you look at this line is dividing this circle into 2 equal parts. So sorry, I don't have paper, so I'm trying to manage this. If you have a line dividing a circle into 2 equal parts, that line, the whole of that line is called diameter, right? And a diameter is joined by 2 radii. That is, if it is just from here to here, it is a radii, and from here to it's a radius, and from here to here it is radius. 2 radii will give you a diameter. Now the question says, what is the area of the circle? Now when we are looking at area of a circle, the formula is pi r squared. So if you see there is no measurement, there's no space for diameter, and in this question what we have gotten is diameter, right? So if we say that diameter is equal to 2r, and we are given that diameter is 8, how can we get our r? By dividing both sides by 2. So radius here is 4. So we now come here, our radius is 4, then you square it. Now 4 square pi, 4 square means 4 times 4 pi, and this is going to be 16 pi. The area of this circle is 16 pi. So this actually, I came across it and I found it so interesting, I couldn't help but just said, okay, let me try this thing out. I hope, yeah. So this is how I looked at this and I was able to come with it. But if you have a better way of solving it, feel free to send in your solution, and then I'll also look at it. Thank you.